Hello everyone, in this video I'm going to be looking at qualitative electrolysis and performing calculations in electrochemistry using Faraday's constant. Right now, during electrolysis, the movement of electrons through the external circuit from an anode to a cathode results in a flow of electrical charge, since electrons possess an extremely small electrical charge. So what that is saying is that, yes, we have our circuit on the right here, and as an electrical charge is flowing around the circuit, now those are our electrodes, we have electrons flowing along with the electrical charge, right? Okay. Now, the quantity of a substance produced at or dissolved from an electrode during electrolysis is directly proportional to the quantity of electrical charge or quantity of electricity which flows through the electrolytic cell. I know that sounds a lot, but what it is saying is that if a certain mass or if a certain amount of electrical charge flows around the circuit, that certain amount of electrical charge will flow with a particular amount of electrons. Not only that, this particular amount of electrons will cause a certain amount of mass to be produced at the electrons. So basically what it is saying is that the quantity of electrical charge is Q, is directly proportional, we use this sign here, directly proportional to the mass of the substance that is deposited at the electrode. Why? Because a particular amount of electrons going around the circuit will cause a particular amount of mass to be produced. So Q is directly proportional to M, where Q is the quantity of electricity. And that's a capital Q. Alright, and this small m here represents mass. Okay, now we scroll. And you might see the capital M going on, but just a small note that in chemistry, usually the capital M represents molarity, so I want you to practice using the small one for mass. Alright, now note that mass of whatever substance that we're using, mass is always in grams. That's the unit for mass. So the unit for mass is in grams, and for the quantity of electricity, the unit is in coulombs. So for grams, you're going to use the common G, and for the coulomb, you're going to use a capital C. All right. Now let us continue. Okay, so it says the quantity of electrical charge flowing through an electrolytic cell during electrolysis is dependent on two factors. So there are two factors that affect the quantity of electrical charge. And by quantity of electrical charge, I'm talking about the amount of electrical charge, right? Quantity means amount. So the amount of electrical charge is affected by two things. The current, let me try to underline that. The current, for current, it's the rate of flow of electrical current or electrical charge that's going around the circuit. So how fast that current is going around the circuit, like what force is actually pushing that electrical current. So, or the measure of that force, let me say it that way. So current affects the quantity of electrical charge. You might see the capital I being used. We use that for current. However, the unit for current it's measured in amperes. So you're going to see the capital A. That's a good way for you to identify whether current is present or not. Then another thing that affects the quantity of electrical charge is the length of time, right? So the time that it takes for this current to go around the circuit, right? And we measure this in seconds. Now this actually gives us this actually gives us an equation where Q, which represents the quantity of electricity, Q is equal to the current, which is I, multiplied by the time taken for that current to flow. Alright, so yes, so it's Q is equal to I times T, and your answer, the unit for your answer should have C in it. Alright. I feel like I should relocate because of the noise. The quantity of electrical charge can be calculated using this formula, which I would have mentioned before. And please note that for the time taken for the current to go around, you must convert this time to seconds. So if you get a particular amount in minutes, it must be converted to seconds.